Greetings! Let's take a look at problem 1 from our week 14 problem set. So this is another critical path method problem, only the ones in the problem set were a little longer than the examples we considered. So the first one, the following table gives the activities for buying a new car. We're going to ask to do a forward pass, backward pass, calculate our total floats, and then determine the critical path. Okay, so just as in the examples, the first step I'm going to take is I'm just going to draw our network in our traditional form, if you will, using circles to indicate our nodes for each activity. Then from that, I'll redraw it only using the essentially the method used in the book, in which the nodes are replaced by this 3x3 table. So that the top line, we can list our earliest possible starting and finishing times from our forward pass. Last row will be latest possible starting and finishing times from our backward pass. And in the middle, in that first cell will be nothing, middle will be the activity, and then we'll have our float, which we'll calculate in the end. All right, but I'm going to try and draw my simple network first, just to make sure I get my connectivity right. Okay, so I'm going to start with activity A, which has no dependencies. And actually, let's keep it as here. Okay, remember, we're going to have some starting node and some terminal node, just to make sure that my network start and ends at a single point. Okay, so my first node is going to be A, which is directly connected to this source node. And then looking at B and C are both just dependent on A. So I'll draw in B and C. I'm going to try and draw my arrows a little shorter to make sure I can fit this all on here. Okay, so there's B and C, which are dependent on A. Then D, E, and F are all dependent on C. Okay, so I'm going to draw in D, E, and F. Okay, and let me try and space them out a little more, all of which are dependent on C. So D, E, and F, which are all connected just to C, or all have a dependencies of just C. Okay, then G is dependent on D, E, and F. So D, E, and F are all precedents for G. H is just dependent on G. I and J are both dependent on H. So let's get I and J on here, both of which are dependent on H. So I and J, both of which are dependent on H. Then K, which is dependent on I and J. So we've got a pretty unique pattern going here. K is dependent on I and J. L, which is a precedence of K. Then M and N, which are both dependent on L. So rather than keep it going, since it looks like so let's draw M and N up here. Okay, and those are both dependent on L. And then O, okay, O we can put right here. O has a precedence of B. Okay, so that's good. So B goes somewhere. M and N. Okay, so this is nice because then all my nodes except O exit and go somewhere. So then just O will go to this terminal node. Alright, so now let's try and redraw that, but we're going to replace the nodes with these 3x3 grids, okay, except for NS, okay, and this stinks, we're going to run out of paper, but we've got this, okay, so I'm going to start with NS, okay, and so NS was directly connected to A, okay, and actually I can make this page, since it's one that I'm drawing, I can make it larger. Okay, so let me flip this. So this way I get some more space. Okay, this way I have some more space as I'm drawing. I can scroll over here. Okay, so NS. So that was connected to A. So I need my 3x3 grid for A. Okay, and then from A, I connected to B and C. So I went from A to B and C. And then from C, I went to D, E, and F. Ah. To D, E, and F. Okay. Then D, E, and F all converged on G. Okay. So let me draw in G. Okay. Then from G, we went to H. And H split off to I and J. Yeah, so G goes to H. Oops. Then H split off to I and J. Boy, I'm gonna need to make my page even wider. And we can do that. And let me get alphabetical order. So the bottom one would be J. Here we have I. This H goes to I and J. Let me make my page wider. Okay. So then I and J go to K, who goes to L. K went to L. And from L, we went to M and N. Okay, and we'll draw M and N up here. Just because then those will go full circle. N. Then Mn and B all went to O. So we can just draw O, say, here. So O has a precedence of B, M, and N. Then O is the only one connected to a terminal node. Bam! Alright, now we need to work through this. So now I need the durations. So going ABC is 3, 14, 1. So 3, 14, and 1. D, E, and F are 3, 1, 2. Okay, let's get G and H. G and H are 1 and 1. I and J. I and J are actually IJK. Let's do IJKL 3, 2, 2, 2. So we have 3, 2, 2, and 2. And we just have MNO. MNO is 4, 1, 3. Four, 1, and 3. All right. Now, let's go through our forward pass. So I'm going to start at time equals 0. Okay. So my source node is only connected to A, so A only has a precedence of my source node. So its earliest possible starting time is 0, has a duration of 3, latest possible starting or finishing earliest possible finishing time is 3. All right, so then we can go to B and then C. So B just has a precedence of A, so its earliest possible starting time is 3, duration of 14, earliest possible finishing time is 17. Okay, go to C, earliest possible starting time is likewise 3, duration of 1, earliest possible finishing time is 4. So from B, I can't jump to O because O also has a precedence of M and N. So I'm going to have to march through my network first here before I can get to O. Okay. All right, so D just has a precedence of C. So earliest possible starting time is 4, duration of 3, earliest possible finishing time is 7, E, 4, and 5. F is 4 and 6. Now G. Okay, so G has a precedence of D, E, and F. So G is going to be held up by the activity that finishes last. Okay, so since it needs both D, E, or all of D, E, and F to finish, okay, D finishes at 7. Can't remember if this is days. I think it's days. So D finishes on day 7, or earliest possible finishing time is day 7, E on day 5, and F on day 6. So the earliest possible starting time for G is day 7. Since all of those need to be completed, right, we're going to be held up by the one that finishes last. G has a duration of 1, so its earliest possible finishing time is 8. H is just dependent on G, so its earliest possible starting time is 8, duration of 1, earliest possible finishing time is 9. I only has a precedence of H. So earliest possible starting time is 9, duration of 3, earliest possible finishing time is 12. J will be 9 and 11. Okay. K, so K has a precedence of both I and J, and so it's going to be held up by the slowest process. Okay, so I'm looking at the maximum of the earliest possible finishing times for I and J. And so its earliest possible starting time will be 12, duration of 2, earliest possible finishing time is 14. L only has a precedence of K, so its earliest possible starting time is 14, duration of 2, earliest possible finishing time 16. Okay. N is only dependent on L, so its earliest possible starting time is 16, duration of 1, so its earliest possible finishing time is 17. Then M, its earliest possible starting time will be 16, duration of 4, earliest possible finishing time is 20. Okay. So now O is dependent on B, which is an earliest possible finishing time of 17, M is 20, and N is 17. So again, it's going to be held up by the slowest activity. And so I'm looking for the max of the earliest possible finishing times for all of those precedence activities. And so that's going to be M, which is an earliest possible finishing time of 20, duration of 3, so earliest possible finishing time of O is 23, which would lead to this entire process taking 23 days. All right, I'm just going to make sure I have my units right. Yeah, days, right? So this is our process of buying a car. So our process of buying a car is going to take 23 days. So now what I'm going to do is I'm going to go backwards. Okay, so now we're going to perform a backward pass. So this whole process is going to finish in 23 days. Okay, we can complete this whole process in 23 days. So my terminal node only has a precedence of O. So that tells me that in order for this whole project to finish on time, that means the latest possible finishing time of O then is 23, since it's the only thing that terminal node is dependent on, has a duration of 3, so the latest possible starting time of O is going to be 20. Okay. Now let's work backwards. Okay. So going from O, okay, so I'm going to need to go from O to B, then M and N. Okay, so before O can begin, B needs to complete. Okay, so if O needs to begin by day 20, B needs to be completed by day 20. It has a duration of 14, so it needs to begin by day 6. Okay. And then from B, I can't go to A because A has a precedence of both B and C, so I'm going to need to know the latest possible starting and finishing times for C. Okay, so then from O, I'm going to go to M and N. So again, if O needs to begin by day 20, then the latest possible finishing time of M is going to be day 20, has a duration of 4, so the latest possible starting time then of M is day 16. N, okay, likewise, it needs to end by day 20 in order for O to begin on day 20, has a duration of 1, so N needs to begin by day 19. Okay. All right, now we look at L. Okay, so we're going backwards. So M and N both have a precedence of L. So L needs to begin, or L needs to be completed before M and N can both begin. All right, so now M needs to begin by day 16, N needs to begin by day 19. So when I look at and try and figure out the latest possible finishing time of L, I'm looking at the minimum of the latest possible starting time. Okay, because if M needs to begin by day 16 in order for the project to be completed on time, and then day 19, well then L better finish by day 16 to make sure M can start on time. Okay, it's 3 days earlier than it's needed for N, but it's okay. L is completed, so N can begin by day 19 without a problem. Okay, so L, latest possible starting time or finishing time is day 16, duration of 2. So its latest possible starting time is day 14. Okay, L just has a precedence of K. So K's latest possible finishing time is day 14, duration of 2. So latest possible starting time is day 12. Okay. So K has a precedence of I and J. So I and J both then need to be completed by day 12. I has a duration of 3, so it needs to begin by day 9. J has a duration of 2, so it needs to begin by day 10. Okay. So I and J both have a precedence of H. So H needs to be completed before jobs I and J can begin, or activities I and J can begin. So again, its latest possible finishing time, I'm looking at the minimum of the latest possible starting time of I and J, and so that's going to be 9, right? Because activity H needs to be completed before I and J can begin, and so it needs to be done by day 9, so activity I can begin on time. That's a day earlier than needed by J, but that's okay. That means J will be able to make that deadline without a problem. All right, H has a duration of 1, so its latest possible starting time is day 8. H just has a precedence of G, so G needs to be complete by day 8, has a duration of 1, so it needs to begin by day 7. All right, so G now has a precedence of D, E, and F. Okay, so that means that D, E, and F all need to begin by day 7 in order for G to begin on time. D has a duration of 3, so that's going to be a latest possible starting time of day 4. E is going to be latest possible starting time of day 6. And F, latest possible starting time of day 5. All right, then D, E, and F all have a precedence of C. So for the latest possible starting time of C, I'm looking at the minimum of the latest possible starting time of D, E, and F. So C needs to be complete by day 4, has a duration of 1. So its latest possible starting time is day 3. All right, so now looking at A, B and C both have a precedence of A. So I'm looking at the latest possible starting time for activity B and C. So A is going to have a latest possible finishing time of day 3 to make sure C can begin on time, has a duration of 3. So that brings us back to a latest possible starting time of day 0. Right? So checks out. Good. All right, so we got this. All right, trying to do undo. There we go to get rid of that big line. All right, now let's go and calculate our floats, and I will star our critical activities. So looking at A, earliest possible starting time and finishing time and latest possible starting and finishing times are the same. So it means I have a float of 0. Okay, so in order for this project to begin, activity A needs to begin on time. Okay, so if I start at B, okay, earliest possible starting time is day 3, the latest is day 6. So we have a float of 3. Okay, so if activity B begins anywhere in this window of day 3 to day 6, the project can be completed on time, so it's not critical. Okay, now I'm going to go through and I'll go through in alphabetical order. C, earliest and latest possible starting times are the same. Okay, so no information's there, so it has a float of 0. It is critical. D, earliest and latest are the same, has a float of 0. It is critical. E, we have a difference of 2 days. And F, we have a difference of 1 day. Right? So there's a 2-day window when E can begin. And there's a 1-day window during which F can begin. And this project will still be completed on time. G, earliest and latest possible starting times are the same. So it's critical. H, it's critical. I is critical. J, we have a difference of 1 day. So you have a float of 1. K, earliest and latest, the same, another float of 0. L, the same, another float of 0, it's critical. M, the same, a float of 0, it's critical. N, we have a difference of 3 though. So we have a float of 3. So we have a 3-day window during which N can begin. And then O, which is our last event in the series, if you will. Start and end times are the same, right? It is critical. All right, and it should make sense that since all of our activities, stem from A and end at O, that both of those are critical. All right, so then our critical path is going to be, so I'm just connecting my critical activities, is A, C, D, G, H, I, K, L, M, O. So all of these activities have a float of 0. They're all critical. So all of these activities need to begin on a specific day in order for the project to be completed on time. Right? For all other activities, we have a float. So there's going to be some window during which that activity can begin, and the project will still be completed on time. And so if I wanted to try and accelerate the project, my focus would be on my critical activities, because it's these critical activities which are going to dictate that project's length. Okay. All right, that was problem 1. Hope that helps. We'll take a look next at project 2. Okay, and I guess just general comment: the problems are a little more elaborate, but as long as we take it step by step and carefully work through the problem, they are relatively straightforward. Okay, and and so again, with this information now, I would be armed to try and look at some project acceleration problems.